Hi, this is a video tutorial showing how to draw objects in one-point perspective. You always start out when you're drawing in perspective by establishing a horizon line, which is a horizontal line crossing the page. A horizon line is basically the same thing as the Earth's horizon. It's the point, or the line rather, far in the distance where the ground plane and the sky appear to meet. So the ground plane is the same thing as the earth, or the surface upon which objects will sit or rest. And then, of course, the sky is above that. So we know that the ground plane and the sky do not actually meet in reality, but they appear to meet. It's an illusion that they appear to meet far in the distance. Another way to think about the horizon line is it's a line that represents objects that are so far away that they have diminished in size to the point that they are indistinguishable from a line. So objects we know get smaller and closer together the further away they move from us in space. And so it's as though they get to be so small that you cannot tell them apart from just a very thin line, which is the horizon line. So the other element that you need in addition to horizon line is a vanishing point. A vanishing point in one-point perspective can be placed anywhere along the horizon line, and placement of the vanishing point on the horizon line just determines the angle at which you're viewing objects. So a vanishing point is also the point at which parallel edges that are moving away from you appear to meet. And I'm going to go into that in a little bit more detail in a second. When you're drawing in one-point perspective, the first step to always think about is to realize that one side of your object is going to be front-facing. So if you're going to draw a cube in one-point perspective, then you would start out just by simply drawing a square, because one side of a cube is a square, and since we know that in one-point perspective one side of the object is always going to be front-facing, then that means that one side of a cube that is facing us would just be simply a square. So start out by drawing the simple shape that establishes one side of the object as just being completely in line with your vision. It's not in perspective, it's not moving away from you, it's flat with respect to your point of view. Okay? That's kind of what I mean by front facing. And then you have to realize that the other sides of the cube are moving away from you into the distance, right? Because perspective is about establishing the illusion of three-dimensional space, height, width, and depth on a two-dimensional surface, piece of paper, a computer screen, that kind of thing. So we have to establish depth, and we do that by realizing that the other sides of the cube are moving away from us. Okay, so what does that mean? Well, it means that you can think about the edges of the cube as moving away from you. And since we know that those edges, that the edges of the cube, I'll draw them for you. This edge of the cube is parallel in reality to this edge of the cube, and also parallel in reality to this edge of the cube. Then we know that in perspective, those parallel edges that are moving away from you will appear to meet at the vanishing point, because that's what a vanishing point is. It's the point at which parallel edges moving away from you appear to meet, receding into the distance, moving backwards in space, moving away from you. They will appear to meet at that vanishing point. So it's a matter of thinking about the object in space and then realizing which edges are parallel to each other, and then establishing a vanishing point for those parallel edges moving away from you. So this is how we pull the edges of the cube back to the single vanishing point. Now, how do we finish off the back end of our cube? Well, you can think about the fact that, again, you can think about what is parallel to what and what's the relationship here. You can think about the fact that the front horizontal edge of this cube is parallel to the back edge of the cube. And this is a line or an edge that is not moving away from us, because this front-facing area, this front-facing part of the cube is just perfectly in line with our line of sight. It doesn't move away from us. So the same thing is true of this back edge. It's nice and horizontal, perfectly straight, because it doesn't move away from us. The same thing goes for this vertical edge here. We know that this vertical edge of the cube is parallel to the back edge of the cube, and since neither of those edges move away from us, that edge will be nice and vertical and does not have a vanishing point. Okay? So that's basics of one-point perspective. Let me show you how to draw we've just drawn a cube here in one-point perspective. Let me now draw a rectangular prism in one-point perspective. Okay, I will draw a rectangular prism above the horizon line, just over here. So again, you first start out by drawing a rectangle. And then realizing that that side of this rectangle is front-facing, none of those sides or edges are moving away from you. However, the left-hand side is moving away from us, and this corner is moving away from us, and this edge here is also moving away from us. And those edges, we know, are in reality parallel to one another, so in perspective they will appear to meet at our vanishing point. And excuse me. And then, of course, the same thing holds true for the rectangular prism as did for the cube. The back edge will be nice and vertical, straight up and down, because it's not moving away from us and it's parallel to the front vertical edge. And the back horizontal edge, we know, is parallel to the front horizontal edge, again because it's not moving away from us, so it doesn't have a vanishing point. Okay? It's only the sides moving away from us that are parallel that have a vanishing point. Okay? Then this time I'm going to draw a cube that crosses, or rather a rectangular prism that crosses over the horizon line. So it's going to start, the base of this rectangular prism will be below the horizon line, and the top of this rectangular prism is above the horizon line. Again, the edges are parallel and moving away from us, so they go to the vanishing point. And the back edge is vertical because it's parallel to the front vertical edge and not moving away from us. Now, this brings up that I've done three cubes like the rectangular prisms rather like this to illustrate one important point, which is that if you draw, and you can probably see this already, if you draw an object above the horizon line, as in this object here, then we will see the underside of the object above the horizon line. Okay, the underside is the part that I'm highlighting in red here. By the same token, if you draw an object below the horizon line, as in this cube down in the lower left, you will instead see the top side of that object. And if you draw an object that crosses over the horizon line, that is neither all entirely above nor all entirely below, meaning part of the object sits below the horizon line and part of the object sits above the horizon line, then you will not see the top side, or you will not see the underside, nor will you see the top side of that object, because it crosses over the horizon line.